So we're going to talk a little bit about excavating subdivisions. It's This is chapter 9, and this will be week 6 that we'll be talking about this. There's a ton of information in this chapter 9 out of grading and excavation, the grading and excavation handbook. I hope to cover some of it with videos, but you're going to have to do some reading. At the end of the chapter, there's 10 questions as usual in this textbook. Of course, you'll want to answer those. I'm not sure what I'm going to do with the tailgate yet. It's just going to be tough to cover all this with videos, and I'm not sure that my videos are going to be getting in your way. We'll see how it goes. I've made notes about most of these sections within here. Well, not most of them, but quite a few of them. And then there's going to be a section on erosion control that you could probably handle better than me making a video of it. It's pretty simple, pretty short. There's Well, I'm just going to cut to the chase and get on with this. The first video I made was uh, from the book, from the very beginning, on excavating subdivisions. I have some stuff highlighted here. It's playing around actually with editing this PDF, and it's going to let me do a few things, but I'm not sure. So the book starts out talking about the best way to keep costs down is to use experienced operators. I'm sure we all know that, but the book really goes into some good examples. Talks about a scraper operator. And that, somebody that I've seen some good scraper operators. You need somebody that can control the bowl. The bowl is what's behind the operator, and of course, if you recall about a scraper, it picks up the dirt with the blade, fills the bowl up, and then ejects it. Well, both picking up and ejecting takes skill. Uh, you have to have good control of the bowl, just like you do a blade on a dozer. You need to know when you're cutting too deep. You need to know when you're coming into soft ground, uh, how to keep from making gouges, let's say. And he knows about grade too. Or she, I keep saying he, but plenty of good female operators out there. Compactor operators are often thought of, just like that's what the new guy does, but there's kind of a bit of an art to it. Back on pavement, there's kind of a pattern that's best to follow. But when you're using dirt, the operator, it's important. It's an important job because they're spraying, running around. We'll talk about the water truck guy here in just a minute, or gal. And they're running around spraying as we're working. So the compactor operator, the compactor usually has a little blade out there in the front, and he needs to keep that dirt stirred up so the moisture can be spread out evenly in there. And it takes a little bit of experience to operate the roller and operate the blade in a way that, of course, again, you're not really gouging, but you need to keep that dirt stirred up. The grader operator. Now, his most important job, believe it or not, is on a big job, is to keep the haul road smooth without bumps. And back to the water truck, it's important that the water truck keeps that road moist, but not so moist that the uh, scrapers are sliding around, running into each other. So it's not just like spraying water and not worrying about things. You got to watch out, be careful how much you put. You put too much on it, and then you shut down on that haul road, and that is a really big no-no. Uh, know when to add and when to quit uh, spraying water. Selecting the right equipment. I wonder, yeah, here it is. I'm really not going to read what you can read. I'm just reading from some notes I wrote down. Selecting the right equipment. I don't know how to say this, but there's a sequence of contingencies, like let's say uh, lot size, elevation between lots, topography, the plans, uh, all of those things matter and make a difference. And in other words, you adjust to the plan, you adjust to the topography, you know, the existing grade, and yet you still got to carry out your task and carry it out accurately. It talks about a really simple project. It says, let's look at a fairly simple project in a flat area. Let's say the lot size, I'm reading from the book, the lot sizes are 80 feet by 100, which is not all that big. And the soil is firm with a little clay, but no hard pan, no rock to contend with. And then when we look at the plans, we see by comparing the existing contour lines with the new elevations to be built that there are no lot cuts greater than 2 feet and no street cuts greater than 5 feet. There are no elevation changes greater than 6 inches between lots, and the engineer's bid quantities show 53,000 cubic yards of excavation and 53,000 cubic yards of embankment. Right here, maybe you can see my cursor. So what we have here is a balanced job. So that takes away a lot of work. In other words, the amount of fill equals the amount of cut. Now, let me catch up with my notes. We have this simple project, and we're going to use that for an example. I think the book does. So I'm going to move the pages. So he says he starts out with scrapers. Now, we have a simple project, you know, which is great. And so he's going to use this simple project to select some equipment, I believe, if I recall, and has a balanced job. He's got an easy scenario for subdivision. You can read all about this on the bottom of page, what am I on here, 156 or something like that, 157. But the description of that I just read you was on page 156, I think. There may be some issues toward the end. You know, some pad elevations may be adjusted, but by and large, it's a pretty simple project, according to the book. So what kind of equipment are we going to use on this? Most of the cut will be in the street. The entire fill will get to the lots, will go to the lots, and no lot cuts are over 2 feet. As discussed before, we were talking about, if you've had introduction to excavation, you're aware that what determines the equipment is the size of the cut or the size of the equipment. So the size depends on the depth of the cut. So we're looking at it like a 2-foot cut somewhere, and I think we saw something that might be, was it 6 in the streets? Most of the cut, no, I was just talking about cuts in the street, and they're going to put that fill back up on the lot. So there's not any haul issues going on in that part. So the book recommends, this is a 30-20, which I think is a 200-yard capacity paddle wheel. It's good for small lot cuts. Uh, for the deeper street cuts, the book, I think, recommends like 2 Cat 631s. That's about a 30-yard open bowl scraper pushed by a D9. And there's a figure 3-9 that shows 2 scrapers right up, actually right here on this page that I'm on. You can see in figure 2-1, there's a paddle wheel scraper. Now, it's not being pushed by anything, but I think there's another picture of a couple of dozers right here. This picture right here has a dozer back here. You can see the blade right there pushing an opal bowl scraper. There's the apron arm. And so that's a bigger scraper, and that's what the book is recommending on this job. And that was in figure 3.9, page 158, I think, if you're keeping score or following us in the book. Yes. Uh, and it kind of ends up saying, as you can see, as you can see, there's a variety of ways to approach the excavation. What's important is to use the equipment that's right for the job, and even more important, not to use equipment that's too small for good production. If you have 90,000 cubic yards to move, you wouldn't use a Cat 615 paddle wheel. Likewise, if you have 5,000 cubic yards to move, you wouldn't want a Cat 61 scraper with a D10 pushing. It's important to know, can we catch up the book with my notes? The production capabilities of each piece of equipment you're considering. If you're not sure about the equipment, contact the dealer in your area for a brochure that describes this capabilities. Some manufacturers supply this information actually on the internet. I think Caterpillar does. They have a blue book. So the number of scrapers depends on the haul distance and the capacity of the scraper. So make sure this is the rule, a rule. Make sure that one piece is not waiting on another piece of equipment to get by. In other words, if you've got a scraper that's waiting on a push dozer, then you need to get another push dozer or another scraper or a bigger scraper. You can't have idle equipment. And let me reiterate, don't get equipment that's underpowered. Let's see, where am I in my notes? Top of page 160. I have some notes on 160. Let's see what's up there. I think I'm close. That's where we were talking about. Here, I think, is what the book wants us to look at. If there's a substantial amount of excavation to be done, I think open bowl scrapers are the most economical way to move dirt. Under most circumstances, they load much faster than any other scraper. It says, of course, if if this is only true, of course this is only true if you have a good operator on board. For instance, there's some good conditions, including sand or rocky soil, when a bowl scraper may not be able to take on full load each time. In other words, you've got a lot of rock and stuff like that. Sometimes the best thing is if you got a half a bowl and you're spinning your tires, just go on, you know. It says it may find that it takes 40 seconds to get 3/4 of load and another 40 seconds to get the last quarter to fill the bowl. It's not cost effective to double your load time for that last quarter load. A good scraper operator will see this happen, so when the loading slows substantially, he'll close the apron, pull away from the push cat, that's the dozer pushing the scraper, and this keeps production up and loading time down. If the foreman has an operator who isn't experienced enough to know when to pull out, he should signal him for a few rounds uh, to, till the operator catches on what he needs to be doing. Uh, Compactors. Let me see what my notes are. Well, let's see. Rule of thumb for sizing the compactor. If the amount of fill being hauled to the compactor daily is 4,500 cubic yards or less, use a Caterpillar 815 compactor. For 4,500 to 8,000 cubic yards per day, that's what the compactor's having to deal with, using 825. We're talking uh, bigger compactors and faster compaction. And remember, in compactions, that scraper needs to be dropping the dirt for the fill in lifts, you know, maybe 8 inches, but your engineer's going to tell you how thick he wants his lifts. On a large fill, it's capable of compacting 12,000 cubic yards per day. That's in a good damp soil. The compactor on a large fill is capable of compacting 12,000 cubic yards per day. So on the bottom of page 160, I think there's a couple of things. Maybe, let me find it. That's 161. There it is. Now it said in good. Oh, I think I just read that, but we'll read it. In good damp soil conditions, the compactor on a large field is capable of compacting 12,000 yards in a day. If they're very dry conditions, this could drop down to 5,000 a day. If the now we're watering also at the same time. If the compaction tests are reading 93 to 95%, if we're getting 93 to 95%, let me catch up with it on the compactor is capable of handling more, the compactor is capable of handling more scrapers. If the compaction readings are 90 to 92%, the balance of scrapers to compactor is just right. So we've got the right amount of equipment, and we're reaching our standards for compaction. This little paragraph here, let's assume our job doesn't have any major soil problems. So for our equipment, we select a 14H, that would be a motor grader with a 14-foot blade. And we have two 631 open bowl scrapers. That's the, 30-yard scraper, I think. And one 628, which is close to that, 628 paddle wheel, one Cat 815 compactor, and a 3,500-gallon water truck. Now that we have the equipment we need, what else is there? Well, there's some other concerns that the book talks about, and I didn't make too many notes on these since I think we all know about this. We got to dial 811, right, to locate the utilities, and we got to get our water permit, pay for whatever it takes to get a water meter put out there, and make sure all the construction signs are up. So the first day of work on the job is usually spent with the grader, with the grade setter marking up fill stakes, placing marking boots next to all the cut and fill stakes. He'll mark the height of the fill on his fill boot. And he'll spray, usually with orange paint, as a matter of fact, I believe it is, the amount of fill needed on the lath in the fill on his, and excuse me, let me start that over. The first day, and the grade setter marking up fill stakes and placing and marking boots next to all the cut and fill stakes. That's something we could talk about a lot right now, but usually there'll be surveyor stakes, and then there'll be the grade setter stakes, and there'll be two right by each other. So he wants to mark the height of the fill on his fill boot and spray the amount of fill needed on the lath in orange paint so the equipment operators building the fill can easily see. So when they get to the top of the orange paint and the boot's there for him to check how close the guy is, right? Remember how to use the boot with a hand level, so that guy's check every time they lay a lift down. The grade check is going to use the boot to check the fill, but the operator can see how much more fill he needs by looking how far up the lath that they've sprayed that orange paint. Oh, and the foreman will make sure that a good water source is available using a standpipe or a water tank. Now, there's some pictures they talk about. So one of them is a pipe with the holes connected to it that goes up kind of like an auger would to a feed bin, but that's not as efficient as having a water tank out there in the field, so the trucks can come and drive under there. It's a lot quicker to fill it. And let me tell you something. Whatever it takes to get these things, it's really well worth it to get what's best. There's no such thing as this'll do. There may be a this'll have to do from time to time, but you want the most efficient way for every task that you can do it within the standards required. So, a standpipe's what it's called when you don't have a water tank and you hook a hose up to it from maybe a fire hydrant, and you fill up that way. That's slower than having a water tank out there. Figure 9.5. I don't know how. There's a water tank. There's a standpipe. Uh, so I think this is where I was gonna end this video, and I am gonna end it here because I have another one I want to get in before I turn this all over to you. Uh, so I'm gonna stop this video, gonna let it load and get ready to make another one.